Today we're going to do some more derivatives. So the problem says find dy dx. So we are given y x cubed, y equals x cubed sine square times by 5x. So in order to do this, we need to know the product rule, which is f prime of g plus g prime of f, and then the power rule, and then we need to know the chain rule, which is f prime of g of x times g prime of x. So let me rewrite it. So the problem is x cubed sine square of 5x. So I will first where you see the sine square, I can rewrite it as y equals x cubed and then bracket sine 5x, raise it to the second power, because that's what sine square means. So when you take a derivative of this, we can use the product rule. So we know that our f is x cubed and our g is sine of the sine 5x raised to the second power. So f prime is really simple, which is just 3x squared. And then you bring down the g, which is sine square, right? Sine square 5x. And then we got to find g prime. So we said that g is sine of 5x squared. So first in order to find g prime, we got to do the power rule, and then we got to do the chain rule. So first, multiply the 2, bring down bring down 2, and then so it's 2 sine of 5x, and then it's just to the raised to the 1 power, because 2 minus 1 is 1. And then you got to take the derivative of sine of 5x, which is the derivative of sine is cosine, and then the 5x stays the same, and then you take the derivative of 5x, which is 5. So our g prime is 10 sine of 5x times by cosine of 5 of x. So we got to add that to our equation. We're going to add that over here. So it's plus 10 sine 5x times by cosine of 5 of x. Okay, now we can actually, let's clean this up. Oh yeah, multiply by x cubed, because that's our f, right? Don't forget the x cubed. So if we were to clean this up, we would get 3x squared sine square 5x plus 10x cubed sine of 5x cosine of 5x. Now, you can actually put this 10x cubed sine 5x cosine of 5x on the left first. It doesn't really matter which side you can put it. It'd still be the same. So that's how you find the derivative of this problem. So to find the derivative of this problem, you need to know the product rule, the power rule, and the chain rule. And that's it.